Hello everyone, welcome to this video. In this video, we'll be showing that this set, which consists of the elements 5, 15, 25 and 35, this forms a group under the operation of multiplication modulo 40. So how does this operation work? If we take two elements A and B, so what we need to do, we need to first of all multiply them, and whatever is the result, we would have to divide that result by 40, and whatever is the remainder here, that would be your answer, correct? So this is the operation. We do not have to do anything about it. We do not have to do anything about here also. We only have to look at the remainder, which is your answer. Right, so let's first of all try to create its Calais table. If it forms a group and moreover its elements, it contains only 4 elements within it, so it would be a finite group, and for this we can very easily construct this Calais table. So let's see how we can construct this Calais table. Here the operation is multiplication mod 40, right? This is your operation. So let's start with this operation. We first of all multiply the element 5 with 5. We have 25, and when you divide 25 with 40, you have 25 as the remainder, right? So your answer is 25. Similarly, when you multiply 5 with 15, you have the element as 75, and when you divide 75 with 40, right, it goes on 1, so you have 35 as the remainder, which is your answer, right? So we have the element 35 here, 5 into 15. What about the next element, 5 into 25? So when you multiply 5 with 25, you have 125 here, and when you divide this 125 with 40, right, you would have 5 as the remainder, so we'll be keeping 5 as our answer. What about the next one, 5 into 35? So 5 with 35, when you multiply it, it would be 175. When you divide 175 with 40, you would have 15 as the remainder, so 15 is the answer here. In a similar manner, you can calculate all such calculations here, and when you calculate all such calculations with 15, we'll be multiplying by 5, 15, 25, 35. With 25, we'll be multiplying with 5, 15, 25 and 35, and then calculating its mod 40. Similarly with 35. So when you perform all these calculations, you have all the digits of this table here, Calais table, and you can see now with the help of this table, we can very easily verify whether this forms a group or not. So let's see the one by one property. So the first property is the closure property. In closure property, you take any two elements from the group, apply the operation, and see if you obtain again the element from that particular set. So here you can see all the entries, they are either 5 or 15 or 25 or 35. So that means all the results, they are again the members of this particular set, hence the closure property is satisfied here, correct? So we have first property satisfied. Moreover, you know multiplication is associative. So in multiplication modulo 40, we are actually multiplying the numbers. So that is also associative and does not matter. So our second property is also satisfied. Now what about the identity? So by multiplying or by taking a multiplication modulo 40 with which of the numbers here would give you back the same number. So we obtain 5 here. For this 25, right? We obtain this 15 here for 15 with 25. We obtain this 25 from 25 with this 25, and we obtain 35 from 35 with this 25. So that means clearly you see 25 acts as your identity. Moreover, this was from the right, we can also check it from the left. From the left, you can very clearly see we have 5 for 5 for what number? 25. We have 15 for 15 for what number? 25. We have 25 for 25 for what number? 25. We have 35 for 35 for what number? 25. So you see 25 is your identity here, correct? Now what about the inverse? For the inverse, we need to check for A would be called the inverse of B whenever we have this as the identity, which in this case is 25, correct? So we are looking for the number 5. For the inverse of 5, we are looking for some element here such that 5 multiplication modulo 40 with that number gives you 25. So in the table, you can clearly see we have this number here as 5 with 5. So 5 multiplication model of 40 with 5 would give you 25. Correct? So that means 5 is the inverse of 5. What about 15? 15, for 15 we obtain 25 for 15 again. So that means 15 is the inverse of 15. Correct? Because we have this expression. What about 25? For 25 also we have the same thing. 25 is the inverse of 25, and for 35 we also have the same thing, that 35 multiplication modulo 40 with 35 would give you 25. So you see here we have all the 4 properties satisfied. So therefore we have this particular set as the group under multiplication model of 40. This is one thing that we wanted to show. Another thing that they are asking to us in this question is, what is the identity of this group? So you see 25 is the identity of this group, right? So you can write here 25 is the identity, and moreover what you can notice here, you can see that this is not available in all the groups. The inverse of 5, the element 5 is 5, 15 is 15, 25 is 25, 35 is 35. So it's basically each element is its own inverse. This is special in this particular group. Next they are asking to us is, can you see any relationship between this particular group and U8? Now if you remember, what is this group U8? This group U8 is the first of all you have to create a set which consists of all the members which are relatively prime to 8 and are smaller than 8. So you see 1 is relatively prime to 8 because GCD of 1 with 8 is 1. 2 is not, 3 is yes, 4 is not because they have 4 in common, they have 2 in common. 5 is yes, 6 is no because they have 2 in common, right? And then 7 is also there, right? So we have to start from 1 and go up to 7. So we have the elements as 1, 3, 5 and 7. So we can construct its Scalar table. It's very simple and you can do it orally as well. 1 into 1 is 1, 1 into 3 is 3 and it is less than 8. So this is only the remainder. 1 into 5 is 5, 1 into 7 is 7, 3 into 1 is 3, right? 3 into 3 is 9. So you have to calculate it under mod 8. So 9 mod 8, what would it be? When you divide 9 with 8, you would have 1 as the remainder. So your answer would be 1, correct? So this is 1. Similarly, 3 into 5 is 15, right? 3 into 5 is 15. 15 mod 8 is how much? It is 7. What about 3 into 7? That is 21. 21 mod 8. How much is that? It would go on 2, right? So it would be 5. Correct? So in a similar manner, you can calculate all the others. 5 into 1 is 5. 5 into 3 is 15. So you again obtain 7. 5 into 5 is 25. 25 mod 8. What would be that? It would go on 2 again. So it would give you 5 into 5 is 25. So yes, it would go on 3 and it would be 24 and the answer would be 1. So this is 1. Similarly, 5 into 7 is 35. 35 would go on 4, right? So you have 3 as the remainder. So here we have 3. Similarly, for 7 you can fill up all the elements. So this is the Scalar table for this particular group, right? Here you can clearly see 1 is the identity here because we obtain the same members for 1, and similarly we obtain the same members for 1 when we multiply it from the right. So here, and what is the operation here? It is multiplication modulo 8 if you do not remember. So here also, can you notice one thing? We have the identity element present at the diagonal, right? In the previous one also we have the this identity element which was 25 present at the diagonal. So that means each element is its own inverse. How? You can clearly see from here that the inverse of 1 is 1. Why? Because 1 multiplication modulo 8 with 1 is 1, right? What about 3? The multiplicative inverse of 3 with 3 is 1. So it is also its own inverse. What about 5? 5 multiplication modulo with 5. So 5, we have 1 here. What about 7? 7 multiplication modulo with 7, right? So what is this? This is again 1. So you see here also each element is its own inverse, and that is what is the similarity between these two groups. right? So I hope you understood this question well. That is it for this video. Thank you for watching.